Hello, and welcome to this quick tutorial on the new Retopology tools for 3ds Max. In combination with the modifier stack, we have a powerful workflow to help you clean up any models that you might need. In this example, I'm going to clean up this simple CAD model that we downloaded from NASA. I want to use the smoothing groups to help drive the topology of the new mesh, so let's just take a look at the smoothing groups real quick. So I'll just turn on the hard edge display, and it looks like the imported model has all of the edges defined as hard. That's not really what we want, so let's clean up the smoothing groups by going to the ribbon, properties, and smooth 30. This will set the smoothing groups by using the angle threshold of 30 degrees. Now let's go ahead and add the new Retopology modifier. The face count's 5000, we have auto edge turned on and using smoothing groups by default. I think that's a good place to start, so let's go ahead and hit compute. Down in the messaging area it gives us the progress, and in this case it's showing we have an error. Let's take a closer look at this model. I can see we have a little area of sliver faces that are hard-edged that we're not really expecting. It looks like probably a narrow band of faces that are all put together, probably due to the translation of the CAD file to the mesh. So let's clean this up. This is actually an easy fix. Let's go back to the ribbon and the freeform tools. Choose the relax, soften brush, and smooth those faces out a little bit. Now that we relaxed out that area, let's try setting our smoothing groups like we did before. This model is symmetrical on the z-axis, I see. So instead of fixing the other side, I can just slice the model in half with the slice modifier. This will also save us time in computing the mesh and make sure the model is completely symmetrical in the end. Let's try computing the Retopology modifier again. Now we have a new clean mesh, and the compute time was much faster. I'm not really happy with the structure of the polygons though. I'd rather have a more uniform face area than this. What can really help us here is subdividing the original mesh. This will get rid of a lot of the long, thin triangles and give us a more uniform triangulated mesh, which Reform actually really likes. The updated Subdivide modifier has 3 new methods of subdivision. Delaney is the fastest, but in this case it's not really giving me what I want. Adaptive, while a little more process expensive, is better, but with the curved surfaces joining into the planar surfaces on the inside of this mesh, I probably need to really dial down the edge length to get enough resolution to make sure that it captures all the detail. In this case, I think variable curvature will do the best. It subdivides significantly in more sharper areas, in this case maybe even too much, so let's dial down the variable density just a little bit. Okay, let's compute again. Much cleaner and closer to what I want. I still see some edge loops that aren't quite as straight as I'd like, so let's increase the amount of regularize and lower the amount of anisotropy and adaptivity. And we compute. Okay, I'm pretty happy with that. Let's add a symmetry modifier and make the whole mesh again. At this point we can even add more detail to the model. I can throw an edit poly modifier on here, add some more detail to the model. This is all completely procedural. If I don't like it, I can turn the modifier off, delete it, and I still have a clean mesh. In the real world, most edges aren't completely sharp, so let's fix that by adding a chamfer modifier to the model. I'll adjust the min angle to parse out the edges that I don't want chamfered. And since this is now a clean model, I can add an open subdiv modifier on top and really smooth out those curved surfaces and not have a faceted look. That's the end of this tutorial. I hope you enjoyed it, and thank you for watching.